Hey, so we're going to put all the stuff we've been doing together. This gives you a purpose, not a bigger purpose, but a littler purpose for doing what we've been doing. For this lesson, because it's two lessons combined, and you can see the lessons in note form but not video form on the Google site in two parts if you choose. But for this lesson, we'll be bouncing between page 20 and page 28 of your workbooklet. Workbooklet is hopefully in your hand as paper, or if you choose, you can look at it on the Google site because I've put it there. So just so you're not completely lost and maybe just a little bit lost, for each of the questions, I've told you where to look. It's kind of tiny. So for instance, this question is page 28. This question is page 20. This is page 28. This is page 20, just to keep you awake. This one's page 20 again. And then we've got a couple of extra questions here. So this probably will be a bit of a long note, and I'll probably take some of the breaks for my hand cramps and also to fill in some stuff so you're not watching me painfully write. So the first question is to factor each of the following polynomial functions. So if it's not factored, that's part of the discussion for today. If it's not factored, then your job is to factor it, and I will tell you how to tell the difference between the two. Then, once you're done that, we will be talking about all of these things except the sixth. Today, we are not talking about whether a function is odd or even or neither. That's just not the case at all. So we'll be going over the other stuff. So not necessarily in order, but I will attempt to color coordinate. So this question is question C off of page 28. And it's actually not factored already. It is considered to be, instead of in factored form, this is called standard form, meaning that there's no brackets, there's no multipliers. It's a polynomial. And a reminder from grade 11 that f at x, which we've seen before, is the same thing as y equals. That means when you see f at x or when you see y equals, your job will probably be to draw or sketch a graph. So the first thing I'm going to do is I'm going to take this space right here and I'm going to factor this. So that's going to take all the stuff we've been doing. Now, this doesn't look to me like a Wayne Gretzky question from the last note. There's no patterns to this. We're just going to have to kind of gut it out. That means the first thing we have to write down is f at x equals, and hey, it's already done for us. The next thing we have to do is we have to find a number, and this is the constant, that divides evenly into 1. So our only choices are 1 and negative 1. That will hopefully give us a 0. And 2 plus 3 minus 1 does not work. So that means 1, the positive version, won't work. So I'm going to race on and hopefully correctly assume that negative 1 will work. So 2 times negative 1 cubed plus 3 times negative 1 squared minus 1. So that's negative 1 times 2 is negative 2. Positive 1 times 3 is positive 3. Negative 1. There's 3 negatives and 3 positives, so that really is 0. And we did, or I did, together we did a really good job of finding a factor. Now that's likely only our only pretty factor. So this is where I'm going to take a break, and I'm going to do the long and synthetic division. So I'm pretending like all these things don't even exist, and I'm just factoring like I would have yesterday, I guess. So let me break, and I'll catch up with you in a sec. So like a Home and Garden Network show, I'm going to just recap. In order to follow step 1, which I'm going to finish here, I need to factor this because it isn't anything fancy. It's not a sum or difference of cubes. It's not a Wayne Gretzky lightning bolt question. We have to do the f at x equals. The f at x has already been indicated for us, so I can try to sub a number in. We subbed in -1. We got a remainder of 0, so that means x plus 1 is a factor. So here is the long division, and here is the synthetic division. And I don't know if you caught the trick. So if I just look at the long division for a second, it goes 3, 2, there's no x term, and then the constant. So I have to insert a 0x, and that is important to remember. So I end up with this quotient and thankfully a remainder of 0. When I go to do the synthetic division, remember you have a choice of one or the other, your job will be to also put in a 0x, but put it in just as a 0, not as a 0x, because you can leave out the letters. We get exactly the same quotient. We get a 0 remainder. So I went on. I restated the question right here. Then I said that f at x was equal to the x plus 1 that we found divided in evenly and the quotient. And then I took the quotient and I factored again because I could. So here's my little green scribblies, and this is what I end up with. Now, I'm not going to finish this question, but I want you to know that if you ever want to find the zeros, that is the exact same thing as the X-intercepts. So the whole point to finding factored form is so that you can find the X-intercepts. Yes, I am absolutely aware that the degree of the function is something I skipped. It should be pretty evident, but I'll come back to it in a second. We'll take care of the Y-intercept. We will not take care of the sketching until I come back to the question. So let's look at finding X-intercepts. Anytime anybody ever asks you to find the X-intercepts, your job is to let y equal 0. And f at x is a fancy way of saying y. So we have that. If you choose, you can dig out the green pen to do your solving. Show as much or as little work. I'm assuming you're trying to get the right answer. And this time I'm going to say that X-intercepts are -1 from this one, a half from this one, and oh my gosh, that one again. So we've got our X-intercepts. Without going into too much detail about what that does for the picture, I just want you to know that whether you look at the original question or whether you look at f at x equals in your factored form, this is a degree 3 question. So a degree 3 question, you can tell here in the polynomial standard form, because the highest power is a 3. If you multiplied this out, you would get x times 2x, which is 2x squared, times x, which is 2x cubed. So this ends up being a degree 3 anyhow, which is supposed to be the case. You're supposed to start with a degree 3 and end with a degree 3. You're not supposed to gain any degrees or lose any degrees. So in doing this much work, which is quite a bit of work, we can figure out the degree. So the degree is 3, and we can figure out the x-intercepts or zeros fairly quickly. So I'm just going to label that stuff. So I was degree, and it was 3. and I was the x-intercepts. Now I will come back and we'll talk about the y-intercepts after I do maybe this question, maybe the next question. But leave yourself a little bit of space, maybe the rest of the page, because we certainly have to finish off this sketch. But I want to show you where you're supposed to be happy before we go on and do the rest of the question. So, this question. With this question, I have given you the exact same instructions, except I took off the factoring line, as in there's no instruction to factor. And that's because this is already in factored form. And I believe everything on page 20 is in factored form. And factored form is amazing. I hope you look at this question, and I hope you don't see a degree 3, and instead you see a degree 2. Because if you took the x from this bracket or factor and multiplied it by the x from this one, you're only going to get an x squared. There's no way to get an x cubed. There's no way to get an x to the 4th. You will end up with a degree 2. The next thing we're going to look at is the zeros, or the x-intercepts. And this is where you're supposed to be happy. This is why factored form is so amazing. If you say you're going to find the x-intercepts, like I said before, that is y equals 0. That's a fancy way of saying f at x equals 0. And because this is already factored, because you've already got your brackets, you can go straight to the green pen if you choose to do it. And the x-intercepts. So we saved a ton of time and paper by not having to take standard form and turn it into factored form. Instead, we can just go straight to that work. Now with this question, I'm going to keep going on. I am going to skip end behavior until the very end of this note. The next thing I'm going to find is the y-intercept. And the y-intercept is, I think, a little bit easier to find than the x-intercept. So I'm going to do it right here in red. So the y-intercept, if the x-intercept is letting y equal 0, the y-intercept is going to be letting x equal 0. So that means I can take my f at x and say it's f at 0 and turn all the x's into 0, so substitute. Do a little BEDMAS. This is multiplication, so we end up with a y-intercept of -12. And yeah, you really do have to label your work because there's a lot going on here. So as I said, end behavior, not going to worry about that. I do want to tell you that because the zeros are also x-intercepts, they're also roots, I'm just going to tell you right away that the answer to 5 is that there's no double roots and no points of inflection, which I write as poise because I'm super lazy. So we'll look at that when the time comes, but I'm going to take all this information and I'm going to sketch. I'm not going to graph. Now, if you notice this particular grid, which I think is given to you on your page 20, you'll notice that the x-axis is labeled with numbers and the y-axis is not labeled with numbers. I don't care if you label anything with numbers. I care that you label your information. So if you decide that your x-intercept of 4 is going to sit right there, you should somehow indicate that to me. And if you want to say that your x-intercept, your other x-intercept is -3, if you don't want to put all those numbers on your grid, you have to somehow indicate that to me. And -12, you just totally fake it. This is what a sketch is, and you somehow indicate that to me. Now I hope every single one of you knows what a degree 2 picture looks like. So this is basically a picture of an x squared, and an x squared is a parabola. Another thing I hope is that when you go to join these dots in a parabola form, you don't do this. And the reason is because you should know from grade 10 and grade 11 that parabolas are symmetrical. And if you make your vertex the bottom or top of your parabola here, that means you've gone a distance of 3 to get to this x-intercept and a distance of 4 to get to this x-intercept, so you're not symmetrical. So I need you to do at least a half-decent job of making things look the way they're supposed to look. So I'm going to bottom out somewhere like here. And this is a sketch. And if this is your picture, I'm not going to take any marks off. That is just fine. If you have speed bumps, or in this case, slow bumps, you are not going to get marks taken off. I mark your information, not your dot joining skills. I'm a little embarrassed by that. Not much better, but I accept it. And that's your picture. Now, we have covered degree, we've covered value of zeros, we've covered x-intercept, we have not covered end behavior, we've covered with this particular question double roots and points of inflection, even though you have no idea what they look like yet. And we are not looking at whether a function is odd or even or neither quite yet. I'm going to look at the next question. And just deciding briefly whether or not I want to do this question first or backtrack, and I am choosing to backtrack. So here is our question that was not very kind because it was in standard form. We needed to put it in factored form. We went to all the trouble to find the x-intercepts, and we found an x-intercept of -1, a half, and -1 again. So I'm going to take those values and I'm going to put it on the grid, just so that I don't forget, because I have to race up and down, up and down, up and down this thing. So I'm going to put that on the grid. So I've already forgotten what it is, -1 and +1/2. Now, I do want to tell you that I don't like this system. I don't like these little numbers. I would never put them there. So what I'm going to do is I'm going to put my -1 here, ignoring the -2, and relabeling, and I'm going to put my half here, ignoring the 1, and putting that there. In fact, on a test or quiz or homework, I'm not going to provide for you a grid. What I care about is that you draw the x and y axis with a ruler and that you label all your points. So we've got that information. We know it's a degree 3. We discussed that. And because it's a degree 3, that means it's not a parabola. The next thing we need to do is we need to find the y-intercepts. So the y-intercept has you let x equal 0. So this is why I wrote all of the f at x's. So you could choose this one to put your 0 into, or this one, or this one. I'm going to choose the original question. I find that's the safest. and this is one of the only things that's good about standard form, is 0 cubed is 0 times 2 is 0. 0 squared is 0 times 3 is 0. Subtract 1. I have a y-intercept of -1. So I'm going to put that on the picture as well. And I'm going to put it wherever the heck I want to, as long as I label it. So I'm kind of hoping you don't want to draw a parabola with these 3 dots, because a degree 3 is not a parabola. So I have to teach you something new here, and it comes up not in end behavior, which I said we're coming back to at the end of all of this. It comes up right now with 5, which is the values of the double roots and points of inflection. So as I said, roots apply to zeros, x-intercepts, or roots. All 3 of those are the exact same name. So if I take a look at our x-intercepts, I hope that you realize that this happened twice. So that means we have a double root, not at -1, but at x equals -1. Now I'm going to not race ahead and tell you that there's no poise, no points of inflection, and a half is just nothing special. So now I have to tell you what a double root looks like. So I'm going to branch off here in space so that I have somewhere to write, and I'm going to tell you what a double root looks like. So a double root is a root, meaning it has to happen on the x-axis. So I'm not even drawing the y-axis because it doesn't even come into play. So a double root does one of 2 things. It either comes from above, hits the x-axis, and bounces up, or the alternative is that it comes up, hits the x-axis, and bounces down. And your job is to figure out, with this picture, at the -1 value, so at this value right here, double root, what happens? Is it a bounce down from where it came from, or is it a bounce up where it came from? And because all of these are functions, because you're in an advanced functions class, because this is a function, you can't backtrack on yourself. So the only possibility for this particular picture is to come from below, to go through that x-intercept, bounce. You have no idea where this is going to end up as long as you come up through the y-intercept and up regularly through the other x-intercept. Now, there is something to be said for this, as in, you don't know a whole bunch of details about this, so somebody else could have a picture that looks like this. Because it has exactly the same criteria. It comes up through the double root, bounces, comes down to who knows where, comes back up through this y-intercept, comes up through this x-intercept, and you don't know what slope this section of the curve has at all. But what matters is that you don't draw anything with a ruler except your x-axis and your y-axis. So what I'm going to do, just for the clarity of this picture, is I'm going to take the purple away, and I'm going to take that away so that you're looking at the final product. So that is what happens with a double root. It doesn't happen when you don't have a double root. So it only happens in the one place. All right. So I'm just going to take a little break here because my hand did cramp after drawing that picture. I don't know if this helps at all. Oh gosh, no. So I'll put her back. And at the end of all this, we do have to go through end behavior. So I'm going to shift some of this stuff around because end behavior really has to do with the end result of your picture. Or in this case, it's called a graph or a sketch. So we'll leave it at that. And I'll come back to you with the next question. All right, hand cramp over. Here's the next question. You're supposed to be happy again. This is in factored form. That means you don't have to do any of this division of any kind. So it's not a long division, it's not a synthetic division, it's just ready to go. So we can start. So if you need to check the list, that's fine. I do not. So the first thing I know we have to do is we have to figure out what the degree is. Remember, this is question B on page 20. So when it's in factored form, you have to imagine taking the x's and multiplying them together. So if you've got brackets, that means you imagine FOIL. So I'm taking negative x times x will be negative x squared. Negative x squared times 2x is negative 2x cubed. And you don't care about the negative, and you don't care about the 2. You care about the x cubed, because that makes this a degree 3. That also means this picture will likely look more like this picture, which is a degree 3, than this picture, which is a degree 2. So let's see how it compares to this one. So next thing we have to do is we have to find the x-intercepts. So we let y equal 0. That means 0 equals negative bracket x minus 1, x plus 4, 2x minus 1. This negative is not attached to an x in any way. It's just a negative 1. Negative 1 does not equal 0 ever. So I can basically ignore that information. I also don't have to write down what I'm writing down now. I'm doing it because this is a note and I'd prefer not to embarrass myself publicly. So I end up with x-intercepts of 1 from this factor, negative 4 from this factor, and 1/2 from that factor. And I do want you to know, new term here, that all of these are considered order 1 roots, meaning they only happen one time each. And if they happen one time each, that means there's no double roots, so no bouncing off the x-axis, and we still have not got to points of inflection, so I'm just going to tell you right now there's no points of inflection. Next up, let's find ourselves some y-intercepts. That means we're going to let x equal 0, so I need to barely see this. So f at 0 equals negative bracket 0 minus 1, bracket 0 plus 4, bracket 2 times 0 minus 1. Now you can do as much or as little of this mentally, but it's amazing how the easy math is what kind of kills you and all this kind of stuff. So like I like to show my work. So negative 0 subtract 1 is negative 1. 0 plus 4 is 4. 2 times 0 is 0. Minus 1 is negative 1. And because this was in factored form, we have to multiply these together because factoring is multiples. So let's see if I can do this without screwing anything up. So negative times negative 1 is positive 1, times 4 is positive 4, times negative 1 is negative 4. So I'm going to take all this information and I'm going to plunk it on my axes drawn with a ruler. I'm going to ignore these things. So I'm going to put my negative 4 x-intercept there. I have the ability to put it wherever I want as long as I tell you that I'm putting it there. I'm going to put my 1 here. And I'm going to put my my positive 1/2 here. And negative 4 is a y-intercept. Be careful. Common mistake for some reason. Don't do things like that. Like I said, it's the silly things that kill you in this course. Make sure that your negatives are negatives and your positives are positives and your 1/2s are inside your 1s, etc. So make sure everything is numerically correct. Now, like I said, there's no bouncing with this, so I can't have any parabola shapes, which is kind of lucky because double roots mean that you have the ability to do this. Okay, it's not listening to me. Come on. Let's try this one more time. Sorry about the hold up. Group. Means you have the ability to do this. And notice that the bracket of x plus 1 happens twice, so you do have an abbreviation for that. And double roots are pretty clearly recognizable here when they're written like that versus this way. But because this is squared, it happens twice and it represents a parabola-like structure. This is not a parabola. This is not a parabola because a parabola does not keep going and do whatever the heck it wants to. A parabola goes either up forever or, if it's upside down, down forever. So this one has no parabola-like structures, and your job is to make sure you join them. Now, I am going to join them wrong. Yeah, I'm yelling at you. I'm not going to join them right here. I'm just going to do something completely wrong. So I'm going to come down through this x-intercept, up through this y-intercept, up through this x-intercept, down through this x-intercept, and then woo! What's that? You can't make up things. So if you have 3 x-intercepts, you can't end up with a picture that has 1, 2, 3, 4 x-intercepts. You have to keep it to 3. So this picture is wrong. That doesn't mean your work is wrong. The bulk of the work comes, or the bulk of the mark comes from the work. I'm going to take all that off and draw a good picture. So most of it was right. I'm going to come down through there, bottom out, come up through here, and down forever. Another thing that can't happen is you can't come down through here, up through here, you can't backtrack on yourself. So you can't swoop backwards in any of the pictures. Sorry about that line. You just got to keep going left to right entirely in your picture. Now what I hope you recognize if you're good with patterns, is that when you have a degree 3, you have an n-like structure on your page. So this is very loosely n-like, and it's also backwards n, and that's what this negative is all about. So I'm going to make you a little summary sheet. I want to say cheat sheet, but it's not really a cheat sheet. I'm going to make you a little summary sheet and drag it to the end. And say, okay, let's talk about x squareds. X squareds look like parabolas, either up or down. These guys are positive, these guys start negative. If you have a degree 3, it is handy to know that these guys are positive, so it starts down, comes up, down, up. So if it reverses itself, it's negative. So at some point today, we're going to look at this and talk about degree 4, which is usually kind of where we stop with this information. So let's take a look at, see if we finished all of this. So yes, everything except end behavior, so I will have to come back to end behavior. Remember, if any of this becomes too much, like right now, that you take yourself a little break and you find some degree 3 questions in any of this information, and you check it out. Now, I'm pretty sure I have solutions for these in your course booklet, booklet number 1. This is infinity, just really, really like the picture. But maybe you take a little break at degree 3 and double roots. We're going to go on, as far as this video goes, and take a look at this question. Now, I do want you to know that this is another Wayne Gretzky question. So I am going to show you how to do this in the quickest way possible. Please recognize that you could just gear it out the way you did here, only it would have to be done twice, because this is a degree 4 question. That also means your shapes don't look like this. So because I need a little bit of space, I lied. I don't need a little bit of space. I'm just going to keep going, and I'm going to turn this into factored form. You ought to recognize, it's me being popular, you ought to recognize that this is in standard form. So, first thing I don't like is that this starts with a negative as the highest degree. I really, really, really don't like that. So I am going to factor out a -1, which means all my signs switch. And then this is actually a pretty tricky, simple trinomial. It doesn't have 2, 1, none. It has 2 times 2, 1 times 2, none times 2. So if I was to factor this, I need to find 2 numbers that multiply to be 81 that can make -18. So that would be -9 and -9. That'll totally work. And because this is an x to the 4 and this is an x squared, that will work. It's only because of the 2, 1, none ratio. Now then, I hope you recognize that both of these are difference of squares. So both of them factor exactly the same way. And this is much easier than if you were to gear it out using the long or synthetic division method. Now, because I'm good with patterns, I'm going to take x plus 3, which is written twice in this line, and do that. And x minus 3, which is written twice in this line, and do that. So this is the f at x that I'm working with that's in factored form. So remember, if it's in standard form, you're good to go. If it's in factored form, not so good to go. I am about to take factored form and find the x-intercepts. And just like in the question before that started with a negative, because that negative isn't attached to an x in any way, it doesn't give you any values, you can essentially ignore it. Now, you also have to keep track of things, which is why showing all your work is a very good thing. So you get -3 and you get +3 as your roots, or x-intercepts, or zeros. This one is in order 2, because it happened twice. This one is also in order 2, because it happened twice. That means that you have a double root at not -3 and 3, specifically x equals -3 and x equals 3. And once again, just because I don't want to lengthen this process too much, but I also don't want to rush things, we have no points of inflection. It does mean that we have 2 bouncing spots. Now, before we determine how it bounces, whether it bounces off the x-axis and returns up or off the x-axis and returns down, we still have to find the y-intercept. That is super useful and also part of the instructions. I'm going to put those on before I forget. So I've got all these f(x)'s that I can choose to use, or I can go back to the original. Remember, my stuff is movable. So I can do f at 0 equals -0 to the 4th plus 18, 0 squared minus 81. And there is so much work going on here that it is advisable for you to tell me what the heck you're doing at each stage in the process. And this time, -0 to the 4th is 0, plus 18 times 0 squared is 0, minus 81. That just means this. So you can actually, in standard form, very quickly find the y-intercept. And there's no way I can fit -81 on that, so I'm leaving it there. So you have to decide, because both of these are double roots, do they bounce like this? Do they bounce like this? Is there one of each? You have to figure out which one works for this particular picture. So the one that works here is that it would come up, hit this x-intercept, come down, likely through that dot, quite normally, up, bounce again. And this picture is very likely completely symmetrical. So you end up with that very, very pretty picture. All right, break for me. All right, so this video is getting a little longer than I expected. So we're going to do one more question and not do end behavior right now. So I don't know if this is D or E, but it's definitely on page 20, and it's f at x equals 2x multiplied by x minus 2 to the exponent 3. There are 3 other questions that I want to do, incorrectly labeled because they say C, D, and E. They're kind of all over the map. What I'm going to do is I'm going to leave everything on this document, and after I'm done eating my supper, I'm going to come back and finish these 3, and then I will go over all of the questions and talk about end behavior. So you are going to have to tune in for end behavior. Sorry about that. So you can fast forward through these if you like. You can just check your pictures if you'd like to challenge yourself. There's a whole lot of options. This question is to sketch using the x and y intercepts, but we will get to that. So let's look at this one. Are you happy? You should be happy. Page 20, factored form. Degree is, tricky here, this is definitely x cubed, pretty obvious, I hope, or obvious now. And then you've got this extra x to be multiplied at the front, so that's actually a degree 4, something we haven't looked at yet. Let's look at something that is familiar, and that is X-Intercepts. Thankfully, I don't have any factoring. I do want to dig out my green scribbles. You really have to pay attention to this stuff. So we have an x-intercept of 0 divided by 2, which is 0, and another x-intercept of positive 2 when you take that across the equal sign. This one is in order 1. This one had a cubed on it, so that is in order 3. So I don't know if you can guess, but that means you have no double roots, because double roots are indicated by order 2. But you do have a point of inflection at not 2, at x equals 2. So I'm going to actually use the scale this time just for fun. There we go. So next thing is, let's take this, which originally had f at x in front of it, and find the y-intercept. Always let x equal 0. For x-intercepts, always let y equal 0. Now be careful with your 0 times tables. I'm not joking. 2 times 0 is 0. 0 times I don't care is 0. So we actually have no extra information about this picture because my y-intercept landed right on my x-intercept. So let's take a little break from the picture and talk about points of inflection. Points of inflection are order 3. That means they don't act like parabolas anymore. But they do happen on the x-axis still. And they do one of two things. You have yourself an x-intercept, and it either starts as a down parabola and switches to an up parabola, or it starts as an up parabola and switches to a down parabola. So that might remind you of the x to the exponent y equals x to the exponent 3 graph from grade 11. That's not a coincidence. Let me get rid of that because it's sort of incorrect. So I know for a fact that I have only 2 choices for this. I have that, and I have this. So I have to figure out which one it is without a helper point. So without, like, I don't know if I'm going to keep going like that or if I'm going to keep going like that. I have no clue. So what I need to do is I need to find some other random, truly random point on this picture. So I found f at 0. I can find f at whatever. That was not me swearing at you. So I'm going to find f at, I don't want to do negatives. I'm too lazy for that. I'm going to find f at 5. Let's see what that does. 2 times 5 times 5 minus 2 cubed is 10 times 3 cubed is 10 times 27, which is 270. So I actually have a point 5, 270 on this picture. I actually don't care that it's 5, 270. I just care that it's 5 something positive, because that means I'm heading up there and not down here. So I just group that together. And I'm going to title that something crazy imaginative like extra info. So now I know that green wins and yellow does not. I can't possibly hit this black dot without doing something ridiculously wrong or extra. So I need to get rid of all that, and I need to use green so I can come down. I'm not sure how far down I can go, but I should meet up with green, do my little squiggle, and head in the general direction of the black dot. I don't have to hit it. I just needed that as information. So I want to add to the picture, or the information here, this was a positive degree 4. A positive degree 4, it's handy to remember that a positive degree 4 looks more like a W than a negative degree 4, which looks M-ish. So if we take a look at this one was a negative degree 4. So I knew, because I have memory aids that I've made up, that negative degree 4s look like M's, so I was not at all surprised at this. You do end up with wonky M's and wonky W's, so this is an example of a wonky W, but I knew it was W-ish. So at any time, you can take a look at some of these. I highly recommend that you join back up for end behavior and this information. We will get there in class, if not by video. So, oh my gosh, I kept it under an hour. Yay me, but still not proud of that. Anyways, catch ya.